All right, welcome back to Honors Chemistry. We are going to do metric conversions today. We're going to use dimensional analysis to do this. So here we go, metric conversions. Now we'll do some conversions involving just the metric system. This process called dimensional analysis or factor label method is really the only way to succeed in this class. You'll notice that I will set up pretty much every problem in this class as a unit or dimensional or factor label. Those are all meaning the same thing. So factor label, dimensional analysis, unit analysis, they all mean the same thing. We're going to use this skill over and over and over again in this class. So you're going to see on these first couple that a lot of it is something that your teacher probably before asked you to just move the decimal place either to the right or to the left. And you very well can do things that way, but I want you to get in the habit of setting up the dimensional analysis the way I have it here, because in the end, when we get further along, kind of like when you did with algebra and you first got like a basic equation that you could do in your head, eventually you got to equations that you couldn't do in your head. And eventually we'll get to things that you can't just do in your head, and you're going to have to use dimensional analysis to get to the bottom of it. So get in the habit of writing it out so that when we do get to those problems, you know how to use this tool and you will be able to do what you need to. Okay, so here we go. Convert 4.75 grams to milligrams. So the very first thing I need to do is I need to look at the units I have here. Let's get into drawing. So the units I have here, I have grams and I have milligrams. So I need to remember the relationship between those two units. Now, if I remember the relationship between those two units, and hopefully you're starting to memorize these prefixes and the relationships between them, I remember that I have 1 gram and I will have 1,000 milligrams as that equivalent. So we're going to use that relationship in this problem. Now we're going to look at the units and what we want to cancel out. We already have grams, so I want to cancel out grams. That means that I'm going to start with the grams on the top, or the first number that we are given. And that means in the next step, so when I look at the next step, I want my grams to be on the bottom of the next step so that when I look at it as a fraction, I will have grams on top from the first step that I wrote down, the first number, and I will have grams on the bottom of the next step. So as a fraction, if I have grams over grams, that means they cancel out. So that's the unit analysis part. We're going to look at units and we're going to move them around with these equivalencies that we know so that we can cancel them out and get into the units that we actually want to know. Okay, so I'm going to take this 1 gram and I'm going to put it on the bottom. And I'm going to take this 1,000 milligrams and I'm going to put that on the top. So when I look at my units, I have gram on the top here divided by gram on the bottom here. That means that unit cancels out. And when I look at my units, the only unit I have left is milligrams. And that's exactly what I wanted for my units. Now, the next thing we need to do is we need to look at the math here. So remember, everything on the top, we're going to think of these as fractions. Everything on the top is going to be a multiplier. And everything on the bottom, we're going to think of them as dividers. Now, the nice thing about having a 1 on the bottom, dividing by 1 just gives us the number that we already have. So that's pretty much the identity property of math or of division. So we don't really have to worry about the 1. So we only really have to worry about the 4.75 multiplied by the 1,000. So if we do 4.75 multiplied by 1,000, we get 4,750. Okay, Now, there's yet a third layer we have to think of here. So if I think of this third layer, I want to look at my significant figures. So in the 4.75, I have 3 digits that are significant. Now remember, I'm multiplying and dividing, so I'm looking at the number of digits in each of these steps, okay? Now 1,000 milligrams in 1 gram, isn't that a definition? So being a definition, that means that we'll have infinite sig figs. So that means I am held to 3 digits. So 4750, if I don't have a decimal point there, that is just 3 sig figs. Remember, only zeros after non-zero numbers with a decimal are significant. Or I could write it like this, 4.75 times 10 to the 3. Both of these ways of writing it would be okay. Okay, next one. Let's look here. So our next one, we have 89.43 liters, and we want to go to nanoliters. The thing that I have to remember is, what is the relationship between liters and nanoliters? So my relationship, if I remember, nano was 1 billionth. So that means I will have 10 to the 9, or a billion nanoliters in 1 liter. That is going to be my equivalence. Now I'm starting off with liters, so I want liters to disappear in the next step. So that means it needs to go on the opposite side, which for this is the bottom. So I'm going to put 1 liter on the bottom, and I'm going to put a billion, or 10 to the 9th nanoliters on top. Notice that cancels out my unit of liters, and I am left with unit of nanoliters, which is what I want. This is what I want. Now let's look at our sig figs. So sig figs, let's get yet another color here. So if I look at my sig figs, 89.43, that has 4 sig figs. And this next one, a billion nanoliters in 1 liter, that is an infinite sig fig, because that is a definition. So I'm going to be held to 4 sig figs. So hopefully you all know how to use your caret key. And by caret key, I mean this key right here. We're going to use that to put in the 10 caret 9 to get the 10 to the 9th. So let me put this in here. 89.43 times 10, and then I'm going to press the caret key, and I'm going to put in 9. So you should have something like this in your calculator. Okay, then we will push enter, and our answer here will be 8.943 times 10 to the 10th. Okay, so notice I've got my 4 sig figs. Here I've got my 4 sig figs. Okay, next one. Let's keep on going. We've got 3.44 seconds, and I want to take it to megaseconds. So I need to think of my relationship. So mega means a million. So I would have 1 million, or 10 to the 6 seconds in 1 megasecond. That's my relationship there. So I'm going to start out with the number that I'm given, with the unit that I'm given, 3.44 times 10 to the 4th seconds. And in my next step, I want seconds to cancel. So I'm going to put the seconds part of that equivalency on the bottom. 10 to the 6th seconds will give me 1 megasecond. Oh. What is going on here? Okay, so I don't want to do that. So I have seconds over seconds. So that means my seconds are going to cancel. And I'm left with megaseconds, which is what I wanted. Okay, but now I do have something that I have to divide by. Remember, we're going to take this, we're going to multiply, and we're going to divide by this. Okay, so I don't know if your math teachers have taught you this, but if I have something that does not have a number in front of it, like this 10 to the 6th, I can basically just take the exponents and subtract it. If it has a number in front of it, then I can't. I actually have to use that number. But I can take these exponents and I can subtract the top and the bottom. So I'll take the top and subtract the bottom. So 4 minus 6 will give me a negative 2. So this would give me 3.44 times 10 to the negative 2 megaseconds. Now, if we look at our sig figs, once again, you're going to probably want to look at the sig figs. I've got 3 sig figs and 3.44, and this one megasecond over a million seconds, that, once again, is a definition. So I'm going to use 3 digits, and that's what I've got. So we could write it like this. You could also write it like this. I prefer, once you're moving the decimal place 2 or more places, I prefer you to use scientific notation, but either way would be acceptable. Okay, so let's move on. Let's do some more. Okay, now we're going to do 2 steps. And in the 2-step problems, I like to go back to the base unit in between. So I like to do the base unit in between. It makes it a lot easier. So use the base unit as your jumping point between the two, if you're going from really small to really big or vice versa. Okay, so we use the base unit for our intermediary or our in-between step. So convert 55.82 micrometers to kilometers. It takes 2 steps because we have to go to meters in between. So if we look at micrometers, we have a million micro whatever into that base unit. And if you look at the, let's see, I did it all in grams, but it's true for all the other base units as well. Okay, so that means I'm going to use that equivalency of, I will have a million micrometers is equal to 1 meter. And notice I want to get out of micrometers. So I want it to be on opposite side in the next step. So it's on the top in the first step. So in the second step, I want it to be on the bottom. So I'm going to put 10 to the 6 micrometers are in 1 meter. So 55.82 divided, right? So this is going to be our dividing. We're going to be dividing by a million, or 10 to the 6. So this is 55.82 divided by 10 caret 6. This will give us 5.582 times 10 to the negative 5. Okay, notice here, I'm sticking with my sig figs. I've got 4 here. I've got 4 here. Here, this is a definition, so that's infinite. So I'm going to start with what I got right here. To do the next step, I need to go from meters now to kilometers. So the relationship is I've got 1,000 meters in 1 kilometer. So that's the relationship I'm going to use in my next step. Now, I have meters here. Oops, I should put a unit here. So I've got 5.582 times 10 to the negative, we said it was 5. And our unit here is meters. So notice in the next step, I want meters to be on the opposite side, so I'm going to put it on the bottom. So I want my 1,000 meters to be on the bottom. And I want my 1 kilometer. Oops, I don't need to put that unit again. It's already there. Notice my unit of meters canceled, just like my units of micrometers up here canceled. And I'm left with kilometers. So we're going to take 5.582 times 10 to the negative 5, and we're going to divide it by 1,000, which you could also write as 10 to the third. So negative 5 minus 3, right, would give us negative 8. And sure enough, if I do it in my calculator, it gives us negative 8 on our exponent. So 5.582 times 10 to the negative 8 kilometers. Once again, sig fig wise, we've got 4 sig figs here. We've got infinite sig figs here because this is a definition. So that means we can report 4 sig figs, and that's what we're going to do right there. Okay? Can I string this all together? Yes. So this is what I'm talking about. When we do multiple steps together, we're going to string it all together. We're still going to use the same factors that we used before. So we want to get out of micrometers. So I'm going to use this relationship and put the micrometers on the bottom, or 1,000,000 micrometers will give me 1 meter. And then the next step, I want my meters to cancel. So I'm going to use this relationship. I'll put my meters on the bottom. 1,000, or I could also write 10 to the 3 will give me 1 meter. So let's see. 55.82 divided by 1,000,000 and then divided by 1,000. Excuse me. So I'm going to put it into my calculator like this with the exponents. And we should come up with the same answer. And indeed we do. So we still come up with 5.582 times 10 to the negative 8 kilometers. Notice our micrometers cancel, our meters cancel, and we are left with kilometers. So we have the unit we want. We got the same answer, but we did it in one big problem instead of 2 small problems. So when we do multiple step problems, we can string it all together with unit analysis. And that's the beauty of unit analysis. I can convert so many things all at one time and just make it one big math problem. Okay, next thing, convert 0.0075 decigrams to hectograms. We haven't really talked about hecto, so let's look at this. Notice the D here is small, okay? So that means deci. So deci, I'm going to use 10 decigrams is equal to 1 gram. And then the next thing, I need to look at gram and hecto. We haven't really talked about hecto. Hecto is 100. So I will have 100 grams is equal to 1 hectogram. So those are my 2 conversion factors that I'm going to use here. Notice I'm starting out with decigrams and it's on the top. So in the next factor or the next step, I want decigrams to be on the bottom. So I'm going to pull the 10 decigrams, put that on the bottom, and that was equal to 1 gram. So notice that cancels out my decigram unit. And then my next factor is 100 grams to 1 hectogram. I want my grams to cancel. So on my next step, I'm going to put my grams on the bottom. So 100 grams will give me 1 hectogram. So gram divided by gram cancels out, and I'm left with hectogram. So when we're all said and done, I need to take this 0.0075 and multiplying it just by 1 doesn't really do anything, right? So this really becomes a division problem. So I'm going to divide it by 10 and divide it by 100 again. Or I could divide it by 10 times 100, which is 1,000. Same thing. Remember your order of operations here. Remember, so when we don't really have parentheses or exponents here. We are really focusing on multiplication and division. So we can do that going left to right every single step. So if we take 0.0075 and divide it by 10 and then divide again by 100, we will get 7.5 times 10 to the negative 6 hectograms. Now, this is already times 10 to the negative 2, correct? Or actually times 10 to the negative 3 is what we already have. And this is negative 1 on our power of 10, and this is negative 2 on our power of 10. So let's subtract what we've got here. So negative 3 minus 1 will give us a negative 4, minus another 2 will give us a negative 6. So that's right exactly where we want it to be here. So we are right in the ballpark. Our sig figs here, we've got 2 sig figs here. This is a definition, so it's infinite. This is a definition, so it's infinite. So we can report 2 sig figs. Okay? So we're right where we need to be. Let's look at this next one. Let's change color. So we've got 5.32 centimeters to kilometers. So we need centimeters to meters for our first switch, and then we need meters to kilometers. So centi is 100. So I have 100 centimeters in 1 meter, and then I have 1,000 meters in 1 kilometer. Okay, so those are the 2 conversion factors that I'm going to need for this. I'm going to start with the number that I'm given as well as the unit that I'm given. So 5.32 centimeters. I want centimeters to cancel. So it needs to be on the opposite side. So the centimeters are going to have to be on the bottom of this next step. So I have 100 centimeters in 1 meter. Okay, so that gets rid of my centimeters for sure. And then, oh, now it changes color. And then on my next step, I want my meters to cancel so that I can get to kilometers. So my meters needs to be on the opposite side, which will be the bottom. So I'm going to put 1,000 meters. I could also, just for the sake of it, I could also write 10 to the 2 and 10 to the 3 meters. 1,000 meters will give me 1 kilometer. Okay. All right. So mathematically speaking, my meters cancel as well. Okay. So 5.32 multiplied by 1 is still going to give me 5.32. Then I need to divide by 100 and divide by 1,000. Or I could look at this. This is times 10 to the 0, isn't it? Right? So 0 minus 2 is minus 2. Minus 3 is now minus 5. So I should get 5.32 times 10 to the minus 5. Let's plug that in my calculator and make sure. Okay? So 5.32 divided by 100 and then divided by 1,000. Yep, sure enough, 5.32 times 10 to the negative 5. Okay, let's look at my sig figs here. Give it a little bit more. Okay, so sig figs. I've got 3 sig figs here. This is a definition on our next step, so that's infinite. And this also is a definition, so it's infinite. So 3 sig figs and my power of 10. Oop. You know what I forgot to do? I forgot to put my unit here. I need to put my unit. Okay. Now, last question. Convert 5.64 megagrams to decigrams. So we need to look at our relationship between mega and gram and deci and gram. So mega, in 1 megagram, I will have 1,000,000 or 10 to the 6 grams. And then in 1 gram, I will have 10 decigrams. So those are the two relationships I'm going to use here. I'm going to start with the number and the unit that I have given. Now I want megagram to cancel. And so I want megagram to be on the bottom so that it's on the opposite side. So I'm going to put 1 megagram, 1 megagram will give me 10 to the 6 grams. So that will cancel out my megagrams. I will be into grams now. Then on my next step, I want grams to cancel so that I can get into decigrams. This is what I want. So I want grams to be on the opposite side, so I'm going to put that on the bottom here. So in 1 gram, I have 10 decigrams. Okay, so that once again takes my unit of grams and cancels that out. Now when we look mathematically here, we have multipliers and our dividers are just 1. So we really just have to look at our multipliers. So 0.564 times 1,000,000 times 10. So that should give us quite a lot. It should give us 5,640,000 times 10 caret 6 and then multiplied by 10. So this is how I am putting it into my calculator. And then, it didn't give it to me in scientific notation. So I'm going to have to actually count over my numbers. So I have 1, 2, 3, 4, 5, 6, 7. So 5.64. 1, 2, 3, 4, 5, 6, 7. 5.64 times 10 to the 7. So that should give me what I've got here. Now sig figs, let's look at our sig figs here. I've got 3 sig figs here. This is infinite because it is a definition, and I have an infinite sig figs because that is a definition. So 3 sig figs plus my power of 10, and then my unit, decigrams. Okay, notice that in working problems that involve only the metric system, the number of significant figures in the answer will solely depend on the original data given, since all the conversion factors are definitions and therefore have an infinite number of significant figures. Now, when we're mixing English system with the metric system, that's not always so. So that will be our lesson for tomorrow. We'll talk to you later. Bye.